Vanakkam. Now we are going to solve problem 3.91 from Fundamentals of Electric Circuits by Alexander and Sadiku, 5th edition and 6th edition. So this is a transistor circuit problem. So whenever you come across this, if this transistor is not given much more details, we have to mark all the details. Okay. So by looking at this, arrow, we come to know that it is an NPN transistor. So this is your base terminal, this is your collector terminal, and this is your emitter terminal. And in the problem itself, only this IB is given. That is the base current. Okay, similarly, you should know how the emitter current and the collector currents are flowing. So we have to mark this currents IC and IE since it is not given, since they are not given. So usually the IC current is entering into this collector terminal. So this is our IC current. Similarly, this IE current will be leaving the emitter terminal. Okay, so we have emitter and collector current like this. And also we know that emitter current is equal to, or it is the sum of the base current and collector current. Okay, then we form three loops here because we are going to solve this problem using Kirchhoff's voltage law. Okay, so this is first loop, this is your second loop, and this is your third loop, which is taken this direction anti-clockwise, because we know that always this collector current is flowing into the collector in this direction only, so that we have taken the direction of this loop in this way. Okay, and similarly now we are going to apply the polarities. See, this would be plus and minus, we know already. And we have taken that the current will be flowing in this direction. So this is from positive potential to negative potential. That's why we have marked here like this. And then between this base to emitter, we have the potential VBE. So always this is plus and this is minus for this VBE. And whenever this emitter current is flowing in this direction, we know that this would take the positive polarity and this is taking the negative polarity through which this IE current is flowing. Okay, similarly this IC current is flowing in this direction, that means this is at the higher potential, so this is positive and this is negative. So you should know that whenever a current flowing like this in this way, okay, any current, then it takes positive polarity here and negative polarity. If a current is flowing in this direction, one point to the other point, okay, so this would be positive and this would be your negative. Like that, you should always understand how to mark the polarity. So for this, if we have taken this as I1 current, then it would be following this path, right? So it is flowing in this way, right, in this direction. So whenever it comes across this 2 kilo ohm resistance, then it is starting point is here, in this is the ending point for this resistance, so it is entering here, right? So entering point is plus and leaving point will be minus. This polarity is for 2 kilo ohm resistance for this I1 current. Okay, and it is following this path and it ends here like that, this loop. Similarly, for this I2, we can start from here. If you want, we can start from here. Okay, so if it starts from here, this I2 will be flowing in this direction. At that time, this would be your plus and this would be your minus. Okay, so then it goes in this direction like this, it goes like this, and then it goes, and here it ends. Because of this entering point for this emitter resistance, that is your 400 ohm, right? So it is your entering point, here it is plus and here it is minus. Similarly, for this third loop, we have taken this anti-clockwise direction, so we can start from here. So you can start from here, it is going like this. Okay, and through the resistance only we have to mark the polarity, so it enters here, that's why it is plus here, and it is leaving here, so it is minus here. Okay, then this point like this, it is coming, and through this emitter resistor it again enters here, so it is plus, and here it is leaving, so it is minus. Okay, these are all the details you should know. Now we take the first loop alone, okay, in order to apply KVL. So already I have told you it starts from here and it follows this path, isn't it? And then it ends here, right? So through which we assume that I1 current is flowing, okay? But this 2 kilo ohm is common for this I1 and I2, so both the currents will be flowing at that particular resistance, okay? Applying KVL to first loop. Okay, so how we write it is minus 3 volts, then that is flowing through 6 kilo ohms, so it's plus 6 into 10 power 3 into current flowing through that one is I1, okay, then plus, because it is entering here, okay, so the entering point is here, it is plus minus, but this I2 current will be entering here and it is leaving, okay, so it is in the opposite direction. So on that case it is 2 into 10 power 3 because it is kilo ohm, right? That I1 is flowing, and then when it enters, this current enters, it is minus for this I2 current, isn't it? Minus 2 into 10 power 3 I, I2, that is equal to 0. This is our first loop equation. So we'll try to simplify this. It is minus 3 plus 6000 I1 plus 2000 I1 minus 2000 I2, that is equal to 0. So we can write this as 8000 I1 minus 2000 I2, that is equal to plus 3. Okay, so this is our first equation. Apply KVL to loop 2. So we can take it like it starts from here, it is moving in this direction like this and it ends here. This is the direction of the I2 current, okay. So when it starts here, this is plus, this is minus, but this 2 kilo ohm resistance is common for this I1 current, I2 current, so that this I1 current is entering here and leaving here. So here at this point, if you see, this is plus for I2, minus for I1. Similarly, if you look at this resistance is RE resistance, isn't it? So this RE resistance is common for the second loop as well as the third loop. So for the third loop, it is coming in this direction like this it comes, so it is plus to minus. Similarly, if you see, this I2 is also entering in this way only, so it is plus and minus here. So both the currents in this case for this 400 ohm resistance, that is the RE resistance, they will be having the plus sign. Okay, so now we'll write the equation. So we start from here, right? So it is plus 2 kilo ohm. So 2 into 10 power 3 into that I2 current is flowing, minus at the same time I1 current is also flowing in the opposite direction. So it is minus sign multiplied by this I1. Okay. So between this base to emitter, we have this base to emitter voltage available, and here you have this positive polarity and here it is negative polarity. So it can be written like plus VBE. Then this emitter resistance plus 400 I2 plus again 400 I3 because it is also flowing in the same direction, that is equal to 0. Now if I expand this, it is 2000 I2 minus 2000 I1 plus VBE is 0.7 volts, it is given in the problem itself, plus 400 I2 plus 400 I3, that is equal to 0. So we can combine this I2's together, minus 2000 I1 plus we go back, what it is, 2000 here plus this is 400, right? So 2400 I2, 2400 I2, then here 400 I3 is there, right? So plus 400 I3, that is equal to minus 0.7. Okay, this is our equation. Now we are going to apply this KVL to the third loop. Loop 3. So what it is, it starts from here and it is traveling in this way. Okay, so it enters here and then here it is entering here, then going along this path. It is minus 9 volt plus 5 into 10 power 3, that I3 is flowing, plus, so between this collector to emitter, this VCE available, it is plus to minus, so we can write it like plus VCE. After that we come across this emitter resistance in which it is entering in this way only. Okay, so again it is plus 400 ohms, that I3 current is entering. Similarly this 400 ohm through which this I2 current is also entering. Okay, so that is equal to 0. So we'll try to simplify this. It is 5000 I3 plus VCE is not known, plus this 400 is there, 400 I3. So when I add both the 5000 and 400, I'll get it like 5400. Okay, so I'll make it a single term, 5400 I3 VCE plus what it is, 400 I2 is also available, that is equal to 9. So if I rearrange it, it is 400 I2 plus 5400 I3 plus VCE, that is equal to 9. Okay, so we got the third equation also. We should know about the currents, like this I1 is some unknown current. There is no more relationship with this transistor currents. Okay, no relation. But if you consider this, if you when you see this I2 is nothing but the base current, IB current, which is flowing, right? Because it is entering into this, the same current is entering into this base, so it is the base current. Okay, IB. So wherever we come across this I2, it can be replaced by this IB. Similarly, if you look into this I3 is nothing but this IC current which is flowing here. Okay, so it is entering here. So this I3 current is the collector current. So I1 current is not a transistor current. But when you look into this I2, it is nothing but IB. It is the base current of this transistor. Similarly, if you look into this I3, it is nothing but the IC current, that is the collector current. So in our equations, wherever we come across this I2 or I3, it should be replaced by IB and IC respectively. Okay, so now we'll see our case of this first equation. So it is 8000 I1 minus 2000 IB, that is equal to 3. This is our first equation. So this is our second equation. In this also we can replace this I2 and I3 by IB and IC respectively. So it is minus 2000 I1 plus 2400 IB plus 400 IC, that is equal to minus 0.7. In this, we know the relationship between this IC and IB, isn't it? It can be written as beta times IB. We know that this beta is 150. So 150 times IB, like that we can write. So now I am going to modify this like 2000 minus 2000 I1 plus 2400 IB plus 400 multiplied by beta times IB. So it is 150 times IB. That is equal to minus 0.7. This is our second equation. So this is minus 2000 I1 plus 2400 IB plus 60,000, right? IB, that is equal to minus 0.7. So it is minus 2000 I1 plus how much IB? 60,000. So 62,400 IB, that is equal to 0.7. This is your second minus 0.7, right? 400 I2 plus 5400 I3 plus VCE equal to 9 ohms. That is our third equation. In this, I3 can be replaced by IC and I2 can be replaced by IB, isn't it? So it is 400 IB plus 5400 IC plus VCE, that is equal to 9 ohms. So it is 400 IB plus 5400 into 150 times IB, right? Plus VCE, that is equal to 9. It is 400 IB plus 8,10,000 IB plus VCE, that is equal to 9. So when you add these two IBs together, we'll get this as 81,0400 8,10,400 IB plus VCE, that is equal to 9. So this is our third equation. So I want to solve this. For that I am going to multiply this second equation by 4. So it is minus 8,000 I1 plus 24,000 multiplied by, it is 2,49,600, that much IB, that is equal to minus 2.8. So this is the modified form of this second equation. So now we have to add this first equation with the second equation. So what do we get? These two get cancelled. So when you find the difference of these two, we'll get this as 247,600, 2,47,600 IB, and this is equal to 0.2. So what is our IB? IB is equal to 0.2 divided by 247,600, that is equal to, we get this as 0.8078 into 10 power minus 6. So that means our IB is equal to 0.0 point, right? 0.8078 microamps. So one answer we get. Now we can find this IC current as well as the IE current. IC, we know that it is beta times IB, isn't it? So it is equal to 150 times this IB value. What is the IB value? It is 0.8078 into 10 power minus 6. So that is equal to 121.17 microamps, or it can be written as 0.121 milliamps. Okay, this is our IC current. Similarly, we know what is IB, IE. We know what is IE. IE is equal to the summation of base current and the collector current. So it is equal to 0.8078 microamps plus 121.17 microamps. So that is equal to 121.9778 microamps. So it is 10 power minus 6 amps or microamps. Okay. So we got the second answer. Seems. So this is our third equation. In this, IB is known, so we can find out this VCE. So it is 810,400 multiplied by this IB is 0.8078 into 10 power minus 6 plus this VCE, that is equal to 9. For this we get this as 654641.12 into 10 power minus 6 plus VCE, that is equal to 9. So this can be written as 0.65464, right? Because it is 10 power minus 6 VCE. That is equal to 9. So VC equal to 9 minus 0.654641. That is equal to 8.345 volts. This is our VC collected to emit voltage. So this is also another answer. So one more thing we need to find out, that is V naught. V naught is nothing but the voltage across the emitter resistance. So it is equal to IE times RE, right? So RE is 400. IE also we have found it out as 121.97 microamps. It is 10 power minus 6 into this 400. This is equal to 48788 into 10 power minus 6. So that is equal to 0.0487 megajoules. So this is our V naught. So this is another answer we got. Okay, so we found the answer for IBS 0.8078 into 10 power 6 amps minus 6 amps, or it is 0.8078 microamps. The second question is what is VCE value, right? So we got the VCE value 8.345 volts. V naught is 0.0487 volts. Okay, so three answers we have. So we have got all the three answers. Thank you.